Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.
Welcome back to Renewables, everybody. Thank you for tuning in this week. We're very excited about the conversation that we're going to be having with Duncan Campbell, VP of Project Analysis at Scale Microgrids. Duncan, thank you for being here.
Hey, David. Thanks for having me. Excited.
Yeah, I really appreciate the conversation. It's a timely conversation because of some sort of world and events that are going on right now that some of our viewers and listeners are probably following. Before we dive into that, I want to give you an opportunity. Just tell us a little bit about your background and experience and how you ended up developing microgrids.
Sure. I guess in college, I studied mechanical engineering, got interested in power and energy and utilities. I don't know, did a few internships with utilities, eventually graduated and got a job with a cogeneration company. They packaged small cogeneration units like 150 kilowatts to 2 megawatts, which at the time in New York City was a really hot market. There were big incentives. Hurricane Sandy had just happened. People were concerned about resilience. Did that for a while and was fortunate to work under some really awesome people. And eventually, some of those folks left. And a little bit later, I got in touch with them and asked what they were doing. And they said they were starting this company that was going to focus more on holistic microgrids, not just cogeneration, but solar and batteries and smart controls and all this. And I begged them to take me with them. And that was Scale. And so here I am. Now we've been doing Scale for 4 years, something like that.
That's great. Well, I appreciate that quick intro. And you touched on cogeneration, which is sort of, I think, probably a good place to start with respect to kind of a microgrid 101. We have a diverse amount of viewers. We have some folks who are really focused in the energy industry and are going to know exactly what we're talking about. But we also have some folks who might not know what a microgrid is, might not know what you mean when you say cogeneration. So if you don't mind, I'd love to start there. Tell us about cogeneration or combined heat and power. Some folks call it, right? Or correct me if I'm wrong on that. They might be two different things. I know there's a lot of different ways. And then after we talk on cogeneration, we'll jump into trigeneration, which is something we were looking at a project together at a trigeneration project, which I thought was really cool. So educate our listeners and viewers a little bit, kind of at a high level. What's a microgrid? What is cogeneration?
Yeah, I'll sort of zoom out here at first and just what is a microgrid? Like what's different about a microgrid versus any other distributed energy project? And the most basic way to think about it is a microgrid project offers both an economic and sustainability value proposition, like most distributed energy projects do, and a energy resilience value proposition. And it does those together in one project. Another way to say this that's a bit more maybe technical and wonky is, in my experience, most distributed energy projects, say a rooftop solar project, offers kilowatt hours, but not really dispatchable kilowatts, right? Whereas a microgrid does. Another way some folks put it is microgrids tend to be islandable systems. So not just can they help you reduce your bill by, reducing the amount of electricity you use from the utility. When the utility goes down, they can also remove themselves from the utility and power you maybe partially or even completely during that outage. So this is debatable, but the most basic form of a microgrid would be a backup generator, right? When the utility goes down, you can fire that thing up. Now, some would say it's not really a microgrid if it doesn't do anything during normal hours. Yeah, it's backup, but does it offer you some kind of benefit the rest of the year? The 99.9% of the time you're not in an outage. And I kind of fall on that side of things. I think a microgrid has to do both. And this is where we get to cogeneration. the sort of original microgrid, in my estimation, is cogeneration. And this is where you have some kind of fueled power plant that is at a customer's location, behind the meter, so to speak, that is generating power for them, but also all the waste heat associated with that power production process is being used for some reason. Whether that's perhaps the waste heat is being turned into steam and being used for some kind of industrial heating load, or very frequent in the smaller cogeneration projects is turning it into hot water and using it to heat a building's, hot water, domestic hot water supply, etc. And then you have this third option, which is trigeneration, where you actually take the heat and turn it into something else. There's types of chiller systems that run on thermal energy rather than electricity, called absorption chillers. So then you can have a system that makes power, heat, and cooling. So this was sort of the first, what I'd say, kind of commercial scale, frequently deployed microgrid system. It makes power for the facility during normal hours, reduces its operating costs, but then also can operate when there's a grid outage and offer resilience. And back when I started this stuff in New York City, right after Hurricane Sandy, a lot of CHP systems were bought, and really they were bought because customers wanted a standby generator that had a payback, right? Mm-hmm. They wanted something that would give them power during an outage, but actually was economically useful as well during the rest of the year. And that's really what the small CHP market in New York City was built on.
Now, in New York City, for example, what are they doing with the heat? Is that mostly being used for steam heat or hot water? I mean, because my understanding, and we've been a part of a couple of cogeneration projects that were good projects, and they were good projects because we could use that heat, right? That's sort of the key to it. So I know every building's different, but in New York City, as an example, where we've seen a lot of this adoption because they don't have room for solar, they don't necessarily have room for huge battery systems. What are they doing with the heat most of the time?
Yep. So usually it's being used either for heating the building, providing domestic hot water, or for cooling the building. So, big New York City building, one type of HVAC design they might have is having a big boiler in the basement, a big chiller in the basement, and a 2-pipe system for each. So you have hot water supply and return, chilled water supply and return, and it supplies the whole building. And so from a CHP project developer's perspective, that's great because you have one central place you can tap into, put all of your heat or put all of your chilled water, and you can access the thermal loads of the entire building. What you'll see sometimes too, and this is particularly, I think, prevalent in kind of like older northeastern cities, is steam heating. Which for small CHP systems can kind of be a challenge. It's hard for them to produce a lot of steam because you need high temperature heat to do that rather than low temperature heat. Mm-hmm. So sometimes you'll use the exhaust from the CHP to create steam, and you'll use, there's basically hot water that comes off the CHP. That's like what in your car is like the radiator. You have that hot water that you'll use either then for the domestic hot water, or for the steam will have a condensate return that needs to be brought. That if you put heat into the condensate return, that's just less work for the boiler to do than to turn that water into steam. That's another strategy people use. But your point is right on. The whole game is CHP is, and this is what everybody says, finding a home for the heat. That's the game. And it kind of bridges how Scale Microgrid Solutions was developed and why. We had been doing these CHP projects, and where they're valuable, or rather where they make sense, they're really valuable. Where you can get that, the right amount of electricity load to heat load, a heating system that's centralized, where all those kind of factors go together in the right way and the stars align, CHP projects can really be awesome. But it's a little bit like finding a needle in a haystack. Your hit rate's really low. There's just all these sort of binary things that can kill deals. So we set out to think, how can we offer this economic sustainability and resiliency value proposition, the microgrid value proposition, in a way that isn't so hit and miss, that isn't so building specific.
Sure.
So we landed on the combo of solar, batteries, and just straight up generators, not CHP, but just standby generators.
So that's kind of your common
Yeah.
project.
Yeah. If you're interested, we can get into that. It's sort of a whole other thing. We still do CHP projects when they sort of show up, but our more sort of common standardized microgrid platform is those three technologies. Just
Sure. Well, I'd love to dive deeper in that. Yeah, I'd love to dive deeper in that. As you know, we're a solar developer. We love the solar business, and we've been in the solar business for quite some time. We have not done as much in the sort of microgrid space, but obviously, as battery technology, becomes more effective, more efficient, cheaper, we're seeing a lot more opportunities to deploy batteries onto our solar projects. So yeah, dive into that a little bit deeper and explain kind of what that means for our viewers and listeners. And let's talk about how solar enhances what you're able to do for your customers.
Totally. Yeah. So yeah, at the time Scale was initially being conceived, we noticed that these multi DER systems, so adding solar, battery, and a generator or something of that nature, produce these kind of like 1 + 1 = 3 type outcomes. They're more than the sum of their parts. And that's why you see like large institutions like the Department of Defense or very large university campuses, things like that, deploying these microgrid systems, because they sort of offer all this complementary value that creates a system that's super beneficial and hits those three buckets that customers want: economic, sustainability, and resilience. What we found, though, is when you bring them down market to everybody other than the DoD and college campuses and the largest industrial facilities, they're very, very difficult to develop. The reason just being the sort of amount of upfront time and energy and engineering and project development required to figure these things out is kind of immense. Just like was the case for these CHP projects we were doing previously. So we tried to solve for that problem. How do we reduce soft costs? How do we make the project development process faster and more reliable, and ultimately higher hit rate, right? Because that, as developers, like that's the game, right? Because every deal you spend time on that doesn't happen has to be paid for by a deal that does happen.
Sure.
And so that's how we landed on kind of taking this more standardized modular type approach, with solar, batteries, and standby generators. And at a basic level, the idea here is traditional microgrid projects are one-off engineered projects, right? You hire a consultant, an engineering consultant or an energy consultant, you pay them 50 grand to do a feasibility study. One of two things can happen. They might say there's no opportunity here, in which case you're just out 50 grand. Or they might say, here's sort of the conceptual design. Here's what makes sense. This amount of solar can fit on your roof in the field next door. This battery will optimize that solar. And then you need either this CHP system or this standby generator to give you resilience. And here's how they'll all work together. Then you'll pay that consultant another 25 grand or something to run an RFP process. You'll bid down all of the elements, here's the solar inverters we're going to use, here's the battery, here's the generator, here's the microgrid controller, bid down the construction, get it, have 50 different GCs look at it, all that stuff, right? And you end up with a cost optimized project. Maybe it's 5% lower CapEx than it would have been. And at the very large scale, that makes a big difference, right? But the problem is you're now building a system that has never been built before, right? Having all those components talk to each other and work and be controlled by one system, all the use cases and the way they're used together, this system has never been deployed before. Yeah. And so there's this massive risk associated with actually having it work, right? And what happens in so many microgrid projects is you build this thing that's never been built before, but no one treated it like an R&D project, right? We think of it as just, power infrastructure, just like a solar PPA. Everybody's expectations are way out of whack. And what you wind up with is a huge commissioning exercise, like systems that never really meet the expectations that were created, project financiers that aren't very happy because they're not producing the revenues they're going to produce, or maybe they were predicted, but now you have customers that are unhappy because they're not getting the savings they wanted, but they're still paying some like fixed fee or something like that. Versus what we do is we pre-engineer our systems. So we have 10 different solar inverters, 10 different standby generators, 10 different batteries, and one microgrid controller. And we pre-engineer any combination of those. So we can go to a customer with a menu of options, and we know that no matter what they select on that, and in reality, what our software selects with their guidance, this is a system we know works because it's all ready to go. And it just massively de-risks the process. So, we can apply capital against projects much more efficiently. We can engage in that pre-contract signature development process much more quickly, and take a little more risk on our side because we know what the outcomes are likely to be, and it makes that sub $15 million microgrid system actually viable in the market.
Very interesting. So with your success in that, have you had luck bringing outside capital into your business through your track record, or are you all funding this out of sort of cash flows and existing developments that you have?
Yeah, for a while, outside capital was tough. It's
I
hard
can
to get
imagine.
somebody to listen to that story I just told, right?
Well, and like you said, it's so engineering heavy that a capital investor, they may not have an engineer on their team who understands that. And so, I mean, are they taking your word for it? Or so that's interesting. I'm interested to kind of discuss your ability to bring capital into that and sort of that pre-engineering, how that's helped get capital investors comfortable.
Yeah, definitely. So yeah, in the early stages, it was tough, right? You go to maybe your everyday solar project financier who's kind of just like, what's the capex and opex and the PPA rate? What's the yield? And you're like, well, back up. We were doing all this stuff, and it wasn't very successful raising capital in a sort of efficient manner. So project to project, we had to find the people that were interested, which kind of ended up being the last piece of the standardization puzzle, right? Like if you don't actually have a reliable source of capital, you can apply against any new opportunity, you really haven't standardized the value proposition. You've only focused on the engineering. Ultimately, after proving out the model, doing projects, showing they both work and they produce the cash flows they project, we were able to raise a fund in late 2019 from Warburg Pincus.
Excellent.
And what I think was pretty interesting about that was, they've invested in a number of things in the energy sector, including some investments in sort of the new energy sector. I don't use the term alternative energy anymore because I don't think it is alternative. But this newer energy tech type space. But a lot of their investment previously has been in oil and gas. And I think the type of story we told about a new development process that unlocks sort of a larger and larger market, but in a familiar space, could remind an investor of even something like fracking, right? It was just combining existing technologies, and now there's this much bigger TAM, right? I think we told a similar story, just obviously in a different space, right? And so they've been awesome partners for the past 6 months. Interesting timing to raise a big fund right before a pandemic hits. But we've kind of pushed through that as well. And yeah, having not just a source of capital, but like a really intelligent source of capital behind us has unlocked that last piece of the standardization puzzle, which is essential for microgrids.
That's great. Now, you mentioned it first, not me, so I'm going to have to go there. Let's talk real quick about COVID. Has that been good or bad for business? I can see from a resiliency standpoint, and then where maybe it's been good. Although, like to kind of elaborate on that, if that's true, and just sort of hear from your take. how is this pandemic? I can imagine. I know in our world, a lot of big capital projects were put on the back burner. But talk a little bit just for a minute about COVID, and has that been good, bad, and different for your business?
Yeah, well, I mean, the short answer is yeah, it hasn't been good for business.
Sure.
I don't want to really say it's good in any way, right? I'm here in New York City where COVID was a disaster. So
Hmm.
it's hard to think about it fondly at all. Um, Generally, though, the business impact, I really wouldn't say good or bad. It's different, right? We found some deals. I'm not going to say fall by the wayside, but sort of slow down. Not become the sort of prime focus of the customer, right? For good
Yep.
reason. Like I had a bunch of hotel deals I was working on. They had much bigger problems to deal with once occupancy went to like 1%. Um,
Sure.
at the same time, to your point, yeah, I think in certain industries, particularly industries with complex supply chains,
Hmm.
this really made them start thinking about resilience. I'm thinking about like distribution warehouses, industrial parks, things of that nature,
Sure.
where we heard all these stories about these supply chains grinding to a halt, and everybody had to scramble to figure out how the meat packing plant was going to work and all this kind of stuff.
Right.
And I do think it's begun to um, have customers are starting to think about energy as part of their supply chain, not just like overhead, not just like, there's rent, there's this and that and energy, but actually an input to what they do. Um,
Sure.
and any smart supply
Sure.
chain manager will tell you, don't have one supplier, like diversify, have different like ways of like mechanisms for your pricing. And that's been big for us. Folks are starting to think about energy a bit more that way, I'd say, because of this pandemic. um, I think that was already happening, but yeah, I think it kind of pushed that evolution maybe a little faster than it otherwise.
Sure. Well, and I think it was happening too. And I want to go quickly to California and blackouts and wildfires because I can imagine that is obviously causing a lot of growth in the microgrid space. And you're up in the Northeast in New York. So, do you all do a lot of projects in California? Have you seen sort of a boom in your business from as a result of these blackouts and sort of energy uncertainty?
Yeah, historically we stayed away from California because it's
Hmm.
in a lot of ways, from a project developer's perspective, um,
Tough.
it's just so unique, right? You
Yeah.
Yeah.
kind of have to be a California specific developer if you're going to do business
Sure.
there. Um, a few years ago, when these public safety power shutoffs started happening because the grid was starting fires, and really the only, at least short-term, feasible way to prevent that was to shut off the grid when it's hot and dry. When that started happening, we did make the choice to pursue California in a very conscious way.
Sure.
Um, so we've been doing that for a few years now, and while I don't spend my time in California, I directly support the team that does, and we have an awesome team out there who's I think like really leading the charge and changing the way people think about their energy options in the
Yep.
state. So what's happening now in California is not only are these public safety power shutoffs an issue, but there's also a more traditional energy crisis, right? There's just not enough supply to meet demand.
Right.
And there's, I don't feel equipped to sort of diagnose exactly what's happening. I think it's very complex. Extraordinary heat wave crushing the entire West right now. Some problems with imports, possibly, et cetera, et cetera. It's really complicated, but ultimately, what it means for customers is, um, over the past few years, the utilities have been shutting off the grid to prevent, massive, damages, destruction, and death. And now the grid is shutting itself off sometimes too.
Hmm.
And so there's this general sense of like, how long do we put up with this for?
Sure.
And no one's talking about going off grid, of course. That's a very expensive, often bad idea. But what can I do to diversify? So as this happens, and customers are being trained to believe it will happen more and more,
Hmm.
am I ready? How do I do that in the most economic way? And basically, there's this huge deployment of distributed energy resources happening in California right now. Most of which, by the way, are just traditional backup diesel generators. That's who we're out there.
Yeah.
Well, it's really fascinating because if anybody who follows the federal space has been hearing resiliency, resiliency, resiliency for several years now, and you've seen some pretty awesome investment in being able to keep a military base running off grid for 48 or 72 hours or however long. But now, and the other thing I find interesting is that um, there may or may not have been a lot of good incentives for stuff like this in California before, but what's stronger than any incentive program is the actual reality of having to run a grocery store or an assisted living community or whatever it may be, knowing that you might not have power for a substantial period of time. So it's fascinating how that resiliency seems to really be driving that. And my next question is, like, if I am a customer in California, what gets Duncan Campbell excited when someone calls up and says, "Hey, I'm running an assisted living community or 3 assisted living communities. Like, who's the best fit for these right now?" And not just from a resiliency standpoint, because I think you can draw those conclusions pretty, again, grocery stores come to mind, need to have power, assisted living communities come to mind, but who is kind of the ideal candidate for you? And I guess why? What makes a person or a customer or an organization a good fit for these types of solutions?
Sure, yeah. The biggest thing, like if you're going to buy a microgrid versus a status quo solution, which on the economic side would just be standalone rooftop solar, or on the resilience side would be a diesel generator. If you're going to go for a microgrid, the biggest thing is that you actually value the resilience. It's not just like a nice to have or like a added benefit that sort of you speak to when you're pitching it to your board, but you actually want it and you're prepared to spend money on it, right? Because if you're about to buy, say, a 1 megawatt diesel generator, we can do so much better for you than that. We can give you something that A, you don't have to pay for up front, B, has a net positive impact on your operations, on the economics of your operations every year, and B, actually supplies better resilience because it's more diversified. It's solar, it's storage, and it's a gas standby generator. Much better than diesel in every way. The other things, though, I would say, beyond sort of the everyday things, like is your roof good for solar? Do you have space in the parking lot for this stuff? Is your switchgear not 70 years old? Beyond like kind of the typical checklist stuff, I think the biggest one is just like, are you the type of organization that is sort of has the mental space to look at something different? And this is something that I think is misunderstood, but losing power is scary for a lot of these businesses. I've talked to grocery stores that in a single 1 day outage can lose like $60,000, all this lost product, lost sales, etc. We also taught, a luxury hotel that said in last year's public safety power shutoff season, they lost $500,000. This is like, there's a lot of pressure to solve this problem if it matters to you. And psychologically, just going for the easy, simple, tested, proven solution, it makes a lot of sense, right? Just go get your backup generator. It'll be fine. So I'd say beyond the technical requirements for microgrid and beyond actually having a need for it and having felt the pain and all that kind of salesy stuff, organizations that kind of have a little mental space for examining a different solution that might be better, that maybe think of themselves as leaders in their industry. Those are the types of folks I get really excited about working with, because they'll take the time to think about this, and they sort of want to show their peers they're doing something that's sort of next level, if you will. And ultimately, what's cool about that too is they're going to get all of that plus better economics, better resilience, better sustainability.
Right. Well, and you kind of answered my question there, which is how do you place value on that resiliency. But in the case of a hotel or a grocery store who just lost all of their perishable, produce or whatever it may be, it's probably a little bit easier to assign value and create that return or payback that everybody so desperately desires.
Well, that's like been the $1 million question in microgrids for a long time. And we have a really, really smart analyst named Gary Digsit who just wrote a blog post on our website about this question exactly. How do you value resilience, and then how does it affect project development once you place a value on it? And I'd suggest people go and read that. But the short answer is there's two ways to value it. One, come up with a number. Maybe you've lost product during outages, or you have some number in mind based on your experience. You felt the pain before and you actually quantified it. Two, use like a more academic sort of standard government index. So there's something called the ICE calculator, but it basically says based on your location, based on your industry, based on the frequency of power outages in your area, et cetera. Here's the cents per kilowatt hour value of lost load. That's one way to approach it. That's kind of like a baseline number. It's often not specific to your situation, but it kind of just provides a backdrop. And the third way is maybe you haven't quantitatively figured out what's the value of resilience, but you want to solve for resilience and you're about to buy a generator. That's the value of resilience. The cost of that generator, buying it and operating, that's the value of resilience to you. So any of those situations are where we can play, right? If you know the number already, great. If you're willing to accept a more academic number, great. If you don't know the number, but you're about to spend a bunch of money, great.
Right.
Any of those, that there's a real value of resilience, and that means we can actually build a system predicated on that. And what you find, and this is the most interesting part, this is super misunderstood in our industry. Adding the value of resilience is not just, let's say it's $50,000 a year, just to make that up. It's not just putting another 50 grand in the pro forma and helping get that deal done. It actually fundamentally changes the project design, often resulting in more solar and more storage, which then creates more non-resilience economics, right? So when you value the resilience, it both changes the project design and therefore creates more utility savings as well. So it really changes like the whole project's conception. This blog post, you got to read it. It's super interesting stuff that I think we're on sort of the cutting edge on.
That's great. Well, one last topic I wanted to cover. We're in the renewable natural gas business. We have a plant in California that's taking food waste that's been diverted from landfills, turning it into renewable natural gas. We're actually then turning it into electricity because of the low carbon fuel standard credits out there. But are you looking at, or have you done a microgrid project that has a RNG component? And do you see that becoming a part of what you do? Because we're actually seeing some opportunities now where like distributed RNG projects are starting to kind of pencil and look really interesting for certain customer segments. So are you seeing that in your business?
Yeah, we're seeing a bit of that. I wouldn't say it's our primary focus because again, we're interested in platforms that are like very scalable, and I think RNG is going to play an important role, but it's not sort of plug and play, right? You got to find the right situation for it to make sense.
Definitely not.
We're looking at some that are really interesting though, and I can't, of course, use the customer's name here, but we're looking at a project, a very large food processor, and that produces a lot of sort of nutrient dense wastewater that they have to treat before they put it into the sewage system, right? And they treat that with a typical wastewater treatment plant. It produces biomethane, and currently they flare it. What a shame that is, right? Flared energy that's renewable, right? And so, yeah, we're looking at a project where, not only do we, refine that gas, run it through a CHP system and make electricity, but most interestingly, and I think this is where RNG down the road will really shine, it will produce their industrial steam that they need as well. And that's something that's really hard to do with electricity, right? Everybody talks about electrify everything as a decarbonization strategy. And in a lot of cases, that's very true. Industrial heat, really hard to do with electricity if you need something like steam, or sometimes maybe not hard, but just expensive. And I think RNG is uniquely capable there. So that combo of uh, cogeneration, creating industrial steam, and firm zero carbon power for utilities is like, that's a pretty magical combo that I think we're going to see a lot of.
Well, I'm glad I asked. I think we should catch up offline about that project. There might be some ways that BioStar can help there. Particularly, I'm interested in the wastewater side of that. So we have some really good solutions for cleaning wastewater. But I want to wrap up with, Duncan, how can our listeners, viewers, how can they follow you? How can they follow Scale Microgrids? You mentioned a great post on your blog. How can people log on, find you all, and track some of this awesome work that you're doing?
Sure. Yeah. First, scalemicrogridsolutions.com. You can find us. You can kind of go down the microgrids route, or you can go down the project finance route, depending on what you're interested in. There's a blog that has some really interesting posts, including the one I said. Our company's on Twitter at Scale Microgrids. And at LinkedIn, I don't actually know, like just search and you'll find it. And yeah, those are really the main ways to connect with us. Myself, also feel free to reach out to Duncan.Campbell at scalemicrogridsolutions.com. I'm on Twitter as well, Duncan_C.
And I think we met on Twitter, right? Actually, a colleague of mine, Peter Gohausen, follows you on Twitter, and he's always chirping into the kind of energy conversation. And I think that's how you two originally met, right? So the power of the social network.
Yeah. Energy Twitter's an interesting place, but surprisingly, so some deal flow comes from it.
That's great.
Yeah. And I'd also be remiss not to plug, kind of in my own time outside of Scale, I help organize a group called DER Task Force, so Distributed Energy Resources Task Force. And it's a group of individuals, not corporate sponsored in any way, that are sort of deep in the distributed energy space. And we do all sorts of stuff. We organize meetups with really cool guest speakers. We have a podcast. We have a really active Slack room that's really interesting. People are like figuring out deals together, sharing studies, all sorts of stuff like that. And then lastly, we've started commenting on policy recently. So on utility docket, pulling together 20 really smart people who know a topic and delivering their comments, without sort of the corporate filter, it needing to go through. So that's been super interesting. So yeah, I'd check out dertaskforce.com as well.
Well, thank you very much. This has been fascinating conversation. Keep up the good work, and really appreciate you taking the time to come on the show today.
Totally. Thanks, David. This was a lot of fun.
Thanks, Duncan. Take care.